Hello, PreCalc. Here we are with 1.6. We're just talking about the library of functions, okay? Just all the different types of functions we're going to see in this unit, in this chapter, in the book, really. A lot of them here. One of the goals is to enable you to recognize the basic shapes of graphs of different types of functions. For instance, you should know the graph of a linear function, ax plus b. All right, you should know all about that. For a line, the domain of the function is all real numbers. The range is all real numbers. You're going to have x-intercept at negative b over m comma 0, and your y-intercept at 0 comma b, increasing if it's the slope is greater than 0, decreasing if it's less than 0, constant if m does equal 0. If it is a flat line, now our range is not all real numbers, it's just going to be one number. Alright, this is probably supposed to be 0. So they want us to practice writing an equation of a line. Looks like we got 1 comma 3 and 4 comma 0. Okay, step 1, we got to find our slope. 0 minus 3 over 4 minus 1. Looks like we got negative 3 over 3 for a slope of negative 1. Negative x plus b. Okay, plug in your points. Let's go with 3 for y and 1 for x. So we'll have 3 equals negative 1 plus b. Add that 1 over. So we should have negative x plus 4. Is that going to work for us? Negative of 1 is negative 1 plus 4 is 3. Negative of 4 is negative 4 plus 4 is 0. That appears to work. Okay, constant function. We talked about f of x just equals a number. If it was just a flat line at 4, okay. Has a domain of all reals and a range of a single number. We just said that a little bit ago. So if it's a horizontal flat line, domain is all real. It's still going forever left and right. We're just not going up and down, so we only are using one number for the range. The identity function, f of x equals x, aka y equals x, you're always going to get 1, 1, 2, 2, 3, 3. This is the same number. That's why it's called the identity. Domain and range are going to be all real numbers because it is a diagonal line. The identity function just has a slope of 1, intercept of 0, 0. Okay, the most basic diagonal line that we can come up with. Then we have the x squared graph, the squaring function, the quadratic function, okay, U-shaped curve. Domain is all real numbers, and for the most basic one, the range is 0 and up. The range is going to be the set of all non-negative real numbers, y's that are greater than or equal to 0. It's an even function, meaning it has, you can flip it over that way. It has vertical symmetry, or it has symmetry over a vertical line. Boom. I don't want it to be confused with vertical symmetry like you're flipping it up. Graph has an intercept at 0, 0. That is also the vertex. Decreasing on this half, increasing on that half. Symmetric with respect to the y-axis. Relative minimum at the vertex of 0, 0. Okay, next after the squaring one, the next common one we're going to use, the cubic function. The cubic function, okay. Domain is all real numbers, and the range is all real numbers for this one, because the cube of a negative number is still negative. The square of a negative number up here, negative 2 squared is positive 4, so we're up top of still. Here, the cube of a negative number is still negative, so we are going to use negative numbers in our domain. Odd function, it's got rotational symmetry. Still crosses at 0, 0. This one's constantly increasing very sharply, then just slightly increasing, and then increasing sharply again. Symmetric with respect to the origin, meaning we got rotational symmetry there, and there's your general picture. So just being able to identify the general shape of a cubic. Okay, square root function, pretty common to see. Domain of just the basic square root of x, non-negative real numbers. Alright, so this is the inverse, or it's partially the inverse of this one. So our domain and range we flip-flopped, right? Before our range was non-negatives, and now this time our domain is non-negatives. Alright, in order to keep this to be a function, if we truly did the top and the bottom here, that would be like the inverse of it. But then it wouldn't be a function because it wouldn't pass the vertical line test. So again, our range is still going to be non-negatives. 0, 0, and we're increasing the whole way. If you wanted to go the other half, you got to split it up into two, right? You're going to have one function that is the square root of x, and then you have to have a second function separate from this one that's the negative square root of x, and then it would match up perfectly with that first one. 1 over x, you worked on that a little bit in Algebra 2 as well. Shouldn't be anything surprising there. The reciprocal function, 1 over x, can't have 0 in the denominator, so we're going to have a vertical asymptote there. The power of x is bigger in the denominator than it is in the numerator, so we're going to have a horizontal asymptote at 0. The domain is everything except for 0, and the range is also everything except for 0. Odd function, rotational symmetry. Okay, no intercepts because it's always constantly getting closer to those axes, but it never crosses them. Okay, decreasing from negative infinity to 0. Parenthesis? Yeah, these are both parentheses. I don't know why these look different. Alright, and it's also decreasing there. Okay. Here's one that I don't know how much you've dealt with before. The step function. The function whose graph resembles a set of stairs is known as the step function. The most famous of the step functions is the greatest integer function, also known as the round down. We got a little typo or a problem here with characters transferring from Microsoft to Schoology probably here, so we're going to have some funky looking stuff. That was probably just supposed to be a regular question mark, but okay, so the greatest integer function is going to be the greatest integer less than or equal to x. Okay, so, and these are greatest integer bars, not absolute value here. So the greatest integer of negative 1 is negative 1. The greatest integer of negative a half. Okay, well, it's not big enough to be 0, so the greatest integer it would be rounded down to negative 1. 1/10, 0.1. That's not bigger than 1, so round down to 0. 1.5 rounds down to 1. 1.7, 1.8, 1.9, all would round down to 1. So it's not rounding based on the rounding rules, like 0.5 go up, 0.6 go up. Okay, it's the greatest integer that it has. It has a 1.5, so round down to 1. What does that look like on the graph? You can kind of see over here. So 0, it would be 0. 0.1 is 0. 0.2 is 0. All the way to 0.99999 still drops down to 0. And then at exactly 1, boom, we jump up to 1. Okay, then the same stuff. 1.5 is still 1. 1.6 is 1. 1.7 is 1. 1.99999 rounds down to 1. And then at exactly 2, we jump up. And that's why the first one's always going to be the solid dot, and then it stays on that level all the way up into the next full integer, open dot, close dot on the next level. It's a little easier to think about building your stairs in the positive quadrant. So maybe start there, and then once you get your pattern, keep that pattern going backwards into the negatives. It's just tough to kind of think about greatest integers. I mean, it's not tough, but I mean, it's easier to make a mistake when you're thinking about it in the negatives. Okay, practice evaluating, and again, some crazy characters here. Let's just go with -1, 0.5, 0, 1, 1.5, 2, 2.6. We'll just practice with those guys. All right, and our function is the greatest integer function plus 1. So -1, the biggest integer it has is -1 plus 1 would be 0. 0.5, oh, I think that was meaning -0.5. -0.5, the greatest integer that it would have, it's not big enough to be 0, it would round down to -1, plus 1 makes it still 0. 0 is an integer, so 0 plus 1, 1. 1, the greatest integer, round it down to 1, plus 1 makes it 2. 1.5 would round down to 1, plus 1 makes it 2. 2 is an integer, rounds down to itself, 2, plus 1 would be 3. 2.6 rounds down to 2, plus 1 is 3. Alright, so you get the idea there. It's the greatest integer, it's the number in front. If it's a decimal, you just drop the decimal. Okay. The negative stuff, it gets tricky to kind of think about rounding down in terms of negatives, so take your time with that. And graphing a piecewise defined function. So a piecewise function where you got to do this over here and this over there. Gets a little tricky. Okay, so we're using -12x minus 6 for x is less than or equal to -4. Less than or equal to -4. You know, so it's a line, so that's not going to be overly difficult. So what you want to do is look for your split point. We're splitting at -4. So I'm going to use -4, and it's going to be a solid dot for this first one. -4 goes in here. -0.5 times -4 should be +2. Minus 6 is going to be -4. So we're going to be at -4, -4, solid dot. Okay, and now we're using this function for x is less than or equal to -4. So now you got to kind of go backwards. Okay, you kind of got to go backwards. So you can keep putting in numbers less than -4, or I'm going to try to do this. So if this was an actual line and I'd be going to the right, I'd be going down 1 over 2. But I'm going left because I want numbers smaller than -4, so I have to go backwards. We're going to go up 1, backwards 2. Up 1, backwards 2. And we're going from here this way. Alright, let's just check it out. Let's try -8. Let's just try -8. -0.5 times -8 should be +4. +4 minus 6 should be -2. That's what we got. Alright, we're here going this way. Then we're going to use x plus 5 for x is greater than -4. So even though we're not going to use -4, we're still going to start here, and we're going to use an open circle. So -4 plus 5 should be 1. So open circle there. Okay, and then we're going to the right because we're greater than -4, so this one's not too bad. We can just follow a normal slope here. We're going to the right. Slope is 1. So 1, up 1 over 1 this way. Yep, we're crossing 5 just like we were supposed to there with our intercept. And there we have it. Okay. If you need to sit down and make a T-chart for this piece, go for it. If you need to sit down and make a T-chart for that piece, go for it, and then graph them individually. That's fine. So just really go slow with those. I would advise going slow with those. So there's our pictures of all the ones we did. Constant, identity, Absolute value, I don't know if we talked about absolute value today, but we have that one in our back pocket. Square root of x, x squared, x cubed, 1 over x, and greatest integer function, aka stair-step function. All right. Make sure we're familiar with the basic characteristics of these simple graphs, and it will help you analyze the shapes of more complicated graphs. In particular, graphs obtained from these with rigid and non-rigid transformations. All right, guys, so there's your notes for 1.6. Feel free to check out the book for more information. I mean, you're going to be in your book anyways to do the homework, so you might as well look at some of those examples. All right, thanks for watching, guys. Let me know if you have any questions.